We are ready to start. So thank you and welcome to my talk on not to FaaS, visible and invisible benefits of the serverless paradigm. Just everything is frozen. Okay. My name is Vadym, and usually I give this talk with my colleague Christian, but due to the school vacation and the special circumstances, I will give this alone. And I'm Ukrainian native, currently living in Germany, and I'm very active in Java user group as one of the organizers of Java user group Bond, and dealing a lot with LWS since 3 years, especially with serverless with 2.5 years. So this talk will cover some general aspects of serverless, when to use it, how to use it, but I will give a lot of examples which are related to LWS because I'm the expert only with this cloud provider. So we are both working for the company called IP Labs. We are writing software for designing and purchasing of the photo products like calendars, photo books, print posters everywhere where you can print your emotions. And we are all in with LWS, migrating heavily since 2 years, gaining a lot of life experiences with serverless that they will be sharing them. So before we start with some general aspects, it's really important to understand the value proposition of the serverless. So let's talk about the total cost of ownership of this paradigm. So it starts with no infrastructure and operational maintenance. And ask yourself, is this your core competency or not? Dealing with infrastructure is for sure the core competency of the data centers, of the cloud providers, but it's probably not the core business where you are in. And if it's so, then it's worth outsourcing, offloading all these competencies to one, which is the core for them. Another thing that you will receive or get with the serverless is auto-scaling and fault tolerance built in. And just also ask yourself, can you get the capacity planning and auto-scaling right? And do you want to solve the hard problem of the fault tolerance by yourself? And we at IP Labs, we have a huge spikes around the Christmas business because people are buying their gifts like the photo book of the year and so on. And we are in business to customer space. So we have to rely on the forecast from our partners, and often they don't really know, especially in these difficult times like currently. And so how can we plan? And as we were in the data center, it was a huge pain dealing with all those aspects of purchasing hardware and so on, and scaling, and then what we will do with this hardware after the Christmas, what the next 11 months. So it's worth considering also uploading all this stuff to the cloud provider, and especially with serverless, you will get this scaling out of the box. Another thing is you can do more with less with serverless. And what I mean by this is that you can start experimenting with new ideas quite quickly by relying on those managed services. And at IP Labs, I saw that the new ideas could be implemented even within days, not even within sprints, because it's so much there that you can set up on. And also you can do simply more with the same amount of people if you outsource, offload all those heavy stuff to the cloud provider, to the serverless managed service. The one more thing to consider is you can have lower technical debt serverless. And I really like this quote from Paul Johnston, who is very, very active in the serverless community. He says that whatever code you write today, it will be always tomorrow's technical debt. And that's kind of true, because even if you need the perfect decision today, is like the US version of the programming language, it will be out of date, out of the support some time ago. So you know this from JavaScript languages, even there will be no backward compatibilities depending on the version and framework. So you have to maintain, you have to rewrite, you have to update things, and it costs you valuable time. The the same is true for security. You know, TLS 1.0 and 1.1 come deprecated. So depending on the version of programming language, you should upgrade and so on. And the same will be true also for web application servers because of the security consideration. And all these servers have also dependency to your programming language, so the version of your programming language you are using. So less code to own and means also lower technical debt. And ask yourself how much time and effort you are spending maintaining your solution over the whole life cycle. That's very important, the whole life cycle, because it's sometimes easy and quick to implement something, add new features, but the whole maintenance stuff occurring around the whole life cycle may take 75% of the whole time. So owning less code, owning less infrastructure, owning less components also mean lower technical debt. And this will allow you to go quickly. So you will focus on business value and innovation. And probably every organization wants exactly this. So to be innovative, to deliver business value. And this will also enable you faster time to market. And in today's business, this is the key differentiator. And but you have also to ask yourself, what is the core of the product you are building and what is commodity utility that you can get as a service. So at Happy Labs, our core are editors and content, so editors for designing photo books, prints, and so on. But of course, we also have e-commerce system, payment, and so on. So just but this is not our core product. So, but we are in the business of trade-offs, and everything is a trade-off currently. So there is no wrong or right answer, and there is no silver bullet to use serverless or FaaS as a service for not function as a service or not. So I prepared some kind of decision checklist, the things you have to understand in order to make the decision to go serverless or not. And just there is no right or wrong answer. It depends on your business, it depends on your company, it depends on your situation, it depends on your product. But we will talk about these things, and I will also talk about the challenges and how to deal with them, how to work around some things. So just let us start with understanding the application lifecycle. You can divide it simply into phases: explore and exploit. And the explore phase is the phase where you want to quickly validate your hypothesis, quickly and rapidly experiment and run this experiment as cheap as possible, because you don't know if it will pay off, if you will have users to the product. And the serverless is really a perfect fit for this. So this is some kind of greenfield project, and you can do things quickly and you can do these things cheaply, because with serverless you pay only for what you use. And if you don't have too much customers, so you don't pay too much, and you don't have to pay on-demand instances or even reserve them to lower the price, because you don't really know how many of them will you need. But of course, if you have already built something which does provide customer value, you will probably enter the exploit phase. So you would like to build something on scale. You would like to build also the profitable product around this. And just here's the situation that you will probably deal with some kind of mixed architecture, serverless and not serverless. And what you should ask yourself, how much of your stack should you own to deliver the business value, and what would you like to outsource? And by outsourcing, I mean outsource service level agreements, regulatory compliance, price roadmap, and everything else to the service provider. And you may end up with a situation that you're a small company and you use some software as a service product, and you have wishes, but because you are small, they won't be implemented by the service provider. So sometimes it's worth considering also that you own the roadmap. So if the service doesn't allow you to implement the plugins and so on, sometimes it's okay to implement the features, even if they are not the core for you, but you will end up owning and maintaining them, and you will have also technical debt around this and so on. But just think about it, what's the best situation for you. If you rely on your provider which deliver new features which is relevant for you, then it's totally okay to outsource things. Another thing is everybody is dealing with existing applications, and you can't magically move them all to service providers, and especially to re-architect them to become serverless, because it's just a huge shift and you can't do this overnight. But what you can do is try to modernize the parts of your application in this so-called Stranger pattern coined by Martin Fowler probably 15 years ago. Then you can put some kind of proxy above your application and then start doing things differently with different architecture paradigms. In AWS, you have API gateway or application load balancer where you can connect your Lambdas, function as a service, and do things simply differently. So this is one thing to consider. Another thing is, which is very important, is so-called FinDev concept. This allows you, the serverless allows you activity-based costing, so on operation by operation basis or features or service, so you can figure out how much one feature, even one request, and then you can compare it, how much does it provide you. And you can even adjust your own pricing on that, because you can check your cost. And if you're in the monolithic world, you probably can't know how much parts of cost you, so you can't do some kind of value-based pricing and so on. And this is very, very powerful concept of the serverless world with the FinDev. So we've covered now understanding the application, and now we will move on to understanding your workloads, your architecture, your application style. And there are some natural fits for serverless. This is event-driven architecture, because nearly everything is event-driven in the serverless world. The same is true for API. Just what we were talking about, the price scale, it may become expensive depending on how many requests you have. Also within, it's really advisable to scale them independently. We at AP Labs have the huge cron job application with all batch jobs, cron jobs packed together, and the situation was that nearly all of them, and with having issues, and then each job depends on another job where everything can stop working, and you deploy living independently, or they won't be dependent on each other. Just the similar situation, the internal tool. So this is how we started at AP. So we had to implement one tool which did heavily computation, but only in the first of the night. And it was waste of resources and money to have servers there. So we looked around other concepts and started to implement all those internal tools with serverless, and we were able to move quickly and also save money and also gain a lot of experience. And now we are doing even live and even other things with serverless. But there are also other workloads or like machine learning, artificial intelligence, big data, and currently there is a kind of mixed situation around this. I see the cases I recently read about Nielsen, which 55 terabytes of data per day, completely serverless, but I think that it might be a bit early to go all in with all those things, but especially in AWS, there are features which are there 1 year, which enable you or will enable you to do these things. And with Lambda layers and Lambda runtime, you can now have your Docker runtime that you can install TensorFlow, MXNet, and so on. So the things which you, libraries which you dealing with machine learning and artificial and elastic policies, which is NFS based, where you can install your programs for processing videos and so on, because it's not possible with a bucket storage like S3 and so on. So this is also kind of door opener to to enable you dealing with machine learning, big data, artificial intelligence, and so on. But there are also other use cases there. For example, do you need specialized hardware, some kind of GPU access? It's currently not possible with Lambda, with AWS. Generally, probably the serverless is not the right solution for GPU-based application, but it's possible with the container that you can assign a fraction of GPU and so on. Another thing is, especially with AWS, if you assign memory, you will proportionally assign the CPU. So if you double the RAM, CPU will also be doubled, but sometimes it's this proportion RAM CPU. You have memory bounded applications, CPU bounded applications, and even network bounded applications. So it might become expensive for you. So ask yourself, okay, is this proportion okay for me, or should I look for other solutions? RAM, but for small also ask yourself, do you need constantly high performance? So if you are in the beginning of gaming business, then you probably need to have response times below 100 milliseconds. It's really difficult to have with serverless because of cold starts when we're talking about this, but constantly low response times is currently really challenging. Another thing is, do you kind of processing a lot of images and writing them to S3 from Lambda or even videos. So Lambda network functions is not really huge. So if you're writing configuration file S3 and so on, or even to elastic file system, that's totally fine. But if you need really huge throughput, you may have challenges. And in the state of serverless computing, will measure the throughput if you write from Lambda to S3, the median and 99 percentile, and you see this latencies around even 300 milliseconds per request, and they can go above. And just this is the confirmation that the throughput is not that good. And of course, you can write this in parallel, but generally you can be impacted for this. So do load test and see how it works with your cloud provider. Another thing is that the function, if you need one function to call the function, there's two lambdas connecting together, just by the service because they are not accessible. And that means that if you have a huge payload for your function, then it should be serialized and then deserialized by the code. And it may take also time. So if you think you need to split your lambdas in case you have a huge payloads to pass, probably it's better solution to merge them. If you're in the asynchronous, if you can communicate asynchronously, there's probably not a big issue at all. But if you have to do the synchronous communication, then think carefully and measure your latencies and so on. So now we're also finished with workloads, and we will be moving to the programming model. I think that nearly providers have the same. The function may fail and all the time and have them to be retried. And there is a policy, and the only one policy supported at least one. That's around S3 or S2S. It's on then Lambda should be called upon, and you have at least once delivery, which means that your Lambda can be called twice. And this means that all your Lambda should be identical. And this is really difficult to guarantee because think, right, is it that important? I think not. Sometimes we don't think about this, and sometimes it's really, it doesn't easy to achieve. If you do the same calculation, then you have the same input, that you will have the same result, and that's totally fine. But if you have some function which writes to the database and then writes to the storage provider, S3 and so on, and in the middle it will be broken, right? And then you have other functions which see something. It might be challenging. So this shifts a lot of complexity to the developers to deal with this ephemericity. So you have to keep track of if the function has already been called or is being called currently, and it's really, really difficult. So we have a lot of messaging systems which have at most once delivery. So this may become challenging, that you will end up that some functions are really difficult to guarantee to be either sure that it's only once. So now to some broader topic, understand your platform limitation. Each service within the cloud provider has a huge so not possible. It's not possible. We will cover the most important one. The first thing, think about, there are so-called cold starts, and then you have to think about in AWS, it's your function behind the virtual private cloud or not. Probably everybody knows what is cold start, but generally speaking, the code for the function has to be downloaded, and then the container, the environment, and it's not Docker container, AWS, it's Firecracker, should be started, and then your runtime should be bootstrapped. In case of you've selected Java runtime, that's a JVM, and so on. So everything should be preloaded, static initializer, and so on. If you're doing this for the first time, these 3 steps are called cold starts, and if you more requests than the warm containers, then also the new phone, and they will also experience the cold start. And depending on the language, it may take even seconds within very simple application. The measurements, depending on their programming language, this year you see with Java, it can be quite below 1 second, but for some old application, you see the lower cold starts within Java and Python. And dependencies to the application can reach the cold starts about 5 seconds. It's really affecting you, and you have to think carefully about the strategies to mitigate them. And one of the features in the other world is so-called provision concurrency. The situation is that and millions of people will receive this newsletter and click on the link, and then you might have a lot of warm containers not experiencing this cold starts, and this provision concurrency allows you to provision these warm containers that can process your functions, and you can do this by saying, I need them from 9 o'clock until 10 o'clock, and then you can shut them down. And you will also pay for them additionally, but you are then sure that the users are not infected. So depending on your programming language, there are a lot of other best practices how to lower this cold starts. It's really relevant for Java and C# programming language. But there is also another aspect. This aspect is if you put Lambda behind virtual private network, and it's necessary in AWS if you communicate from your Lambda with Elastic Cache, Elasticsearch, or your RDS, this is managed relational database, with one exception. And situation was until the last year that it could add up additionally 10 seconds to your cold start. And it's been fixed with another approach, and you will have this 1 second, but generally it may be additional to the cold start, depending on your programming language and so on. So the situation is putting Lambda behind the PC and using these services. For example, just don't be scared of your cold starts, because if you communicate asynchronously, them also in your container world. So the situation is that your container may be full, and you need another servers to postpone, and then it may take 20 seconds. And the strategies to deal with them is to auto-scale earlier. For example, if you have CPU utilization of 40%, you auto-scale, but in this case, you overpay and over-provision. So this is some kind of trade-off between cold starts and overpaying and over-provision, and just think what's the best solution for you. But generally, and then there is another issue you may run in small connection limit of your relational database. And on the database selected, in case you it will be that large, it will be doubled to 900. And if you have may run out of these connections and just can communicate within database. The situation is that Lambda, the small functions which may run quickly, are not very good fit for communicating with the relational databases, because there you rely on connection pooling and so on, and these are short-lived functions. If the function in 1 hour, the whole container may be released, so then the new container has to be started and so on. So this is dealing with connection pooling. It's really challenging. Of course, there are solutions to think about using NoSQL database like DynamoDB and so on, but probably you have reasons to stay within your releases. And then you have two other options, AWS proxy in the AWS world, and also data API for Aurora Serverless. And the DX proxy, which is available for MySQL and also Postgres, will allow you to proxy connections, so your client will only deal with not so many connections that you come out of it. And the Postgres users know this concept like digit bouncer and nothing, so to proxy the connection and just not running out of limit. Another option, use Amazon Aurora, this cloud-native relational database, the serverless flavor of this, and especially this data API. Also available for MySQL and Postgres. And what is allowing you is to communicate within your relational database over HTTP, a similar thing to DynamoDB. So just communicating over HTTP means that you don't have to do with connection pooling at all. So this will be abstracted away. So this is also another possibility to stay within a serverless with a relational database and just don't think about this connection problem. So there are also other limitations. The account-wide limit, how many lambdas you can run in parallel. You're running, but generally between 500 and 3,000. This is a soft limit. You can raise it if you request this, and also other limits like invocation duration, currently 15 minutes, but tripled 2 years ago, and also API gateway, this public HTTP traffic, it's only allowed 29 seconds. So if you have your API gateway calling Lambda, which is generally the best practice in Lambda, may run more than 29 seconds, you will still experience the timeout. And that's probably the right thing, because you have API gateway for some kind of communication with the so public-facing API, and probably nobody wants to wait even 29 seconds. So for public-facing API, you should strive for minimizing this request response trip. I think seconds are too much. So, and you can assign only 3 gigabytes of memory to your Lambda, which is totally fine. Nevertheless, if you so it's only feature, but for the most use cases, you can do a lot with 3 gigabytes of memory. So now moving to another part, and this is the cost, and especially understand your bill and understand your cost at scale. And this is the invoice application that I delayed. and you see Lambda costs for fraction of %. So there are a lot of other cost drivers. There are part of APIs. It may be pricey. The pricing starts with $10 per million requests, but if you do billions of them, it will be cheaper. But generally, if you have million requests every 5 minutes, it will impact your view. You may use application load balancer instead of API gateway, then you will lose all these features like throttling and so on. But generally, so if you are not heavily API driven, then it's probably not a huge issue. Otherwise, there is another possibility at AWS world, like HTTP APIs, which were released half of the year ago, and this is the alternative, which will be 70% cheaper and more performant, and it's well for most use cases, but there is no connection between HTTP APIs and API gateway. But this is the goal of AWS, so they improve a lot the API gateway because they recognize that they may become expensive. Also, DynamoDB, and there you have two options: provision throughput and on demand. And with provision throughput, you have to deal with read and write capacity units, so you have to think a lot about provisioning, taking away certain specific ranges, of course. But generally, if you have resources chosen on demand, you have that for the provision capacity. Yeah. We have a higher workload, so the cost probably better. You think total cost of ownership, not to deal with all this provisioning stuff, you will probably even win. I see less on demand because they have some spikes, and then for the low utilization, they have the provision for those spikes. So on demand, it's also taken away. There's then other cost drivers like loading, monitoring costs, all this loading and monitoring stuff really adds up to your bill. But there are also other drivers like extra costs. They are really depend on traffic or in availability zone traffic. So there is a diagram most expensive at the $5 per million transitions. Also, if you enable cache, we also have other things like just memory or other Elasticsearch and so on. And the thing is, just think about if you add caching, then you will pay the servers running 24/7, even the whole application is serverless. You also have remote API calls and third-party services and so on. They have their own price model. So I see that the people say they have with the sound. Is this still true? Or it's better currently? Okay, we'll move on. Probably the host can say something with the experience features, with experience low quality. Okay, I read it's currently better now. So we will move forward to another understanding your organizational environment. So structure, how your organization is structured, what are your ability, knowledge, and even culture. Yeah, every organization is different, and to be successful with serverless, ask yourself, do you already embrace DevOps best practices? And often you will find yourself with classical operational people. They are not very happy if you move to serverless because just there is no server, there is no agent to install, and so on. They have been quite uncomfortable in this situation. And I often refer to the top problem, what do we do if the server goes away? Here's the person who came from the operational background, dealing currently with a lot of serverless stuff. And there he talks about challenges where the ops people can be in charge or can help developers and the organization and the services so to grow. And probably you won't end up being completely serverless. So you will have other architectures, but what you should have for your whole application is the whole monitoring and alerting for everything together. And they are really quite good at this, the operational people, and also chaos engineering and game days. There's also important things with fault injection and so on, and the operational people are really sensitive. Also infrastructure code and even testing of infrastructure. So this is the most important part. Infrastructure code should be done by everybody, but then you see some improvements from your cloud provider, so even how infrastructure as a code may break, and it also has to be tested. And probably the most difficult part, the constraints of AWS services and choose the right service in terms of scaling, in terms of pricing, so they choose the right service for the current situation, for current requirements, and for some time in the future. So you don't want to architect each year, but you probably have to find some kind of solution which will stay, and then you can rethink your requirements and then easily re-architect. And one example is, for example, event source. You can choose an AWS. And you have a lot of options like Kinesis, SNS, event bridge, and even combinations of these services. So how to choose them, and what you have to understand how they scale and how they are priced. And what you see on the right side, if you have only one with 1 kilobyte size, Kinesis is the most expensive service because it will be scaled by shards per hours and put requests, and SQS and SNS are SNS and SQS is the option to go, or even the combination of them. But from 1 message per second to 1,000 messages per second, we have different pictures. So now the Kinesis service is the most cheapest one, and SNS and SQS became more expensive because they are priced by message. So just there, the operational people are very sensitive. They go for all these constraints. They have done this for storage, operating system, for databases. So I see that the developers often overlook all those aspects, and then they see, okay, that's not the best fit, and the operational people may have them to look at the question. So just a lot of challenges the operational people may have. Of course, they have to work differently, and also developers have to work differently within those teams, that they also take care of the operational parts. But generally, what Simon Wardley, that each evolution goes through something completely new has been through custom build, and then the function and the service providers like Azure functions, like AWS, Google functions, they currently became commodity because nobody in order to be best practices. This is similar to if you rely on NoSQL database, you cannot do this with the best practices from the relational databases because it will fail. And the same is also true for the serverless world. So Simon Wardley calls this co-evolution of practices, and what I would like to do is to share some of them with you, which I currently see. And the first thing we'll talk about is operational stuff. There is a very good page called DevOps Topology. See the link below. the authors share the best experiences and anti-patters working with DevOps. And probably the only one thing is really good fit for serverless is through DevOps, where devs and ops fully share their responsibility with one team. So you can have some ops team and in serverless, so you have to do everything from end to end to the staff and work together with this. Another aspect is that the responsibilities for the invoice, for cost optimization, they also go into the teams. And also ask yourself, are you in the organization where this kind of working is allowed? Because if you're in the data center, then probably your bill is more or less static. So there should be a lot of trust in developers that they recognize all these expensive parts, and also cost optimization becomes a feature like security, performance, and so on. So you have to rely on alarms if you see that something the cost become too high and so on. So the developers should have this financial responsibility to optimize things. Also complete infrastructure automation, I think that is the core. The serverless world, chaos engineering, game days, this fault injection and so on is really important in this whole ecosystem. And also what is possible with serverless, if that whole automation in place, then each team or even each developer can get its own AWS account feature, not only for all features running, but even for per feature. Because with serverless, it's that cheap. Yeah, you only pay for what you use, and you probably don't have high utilization on your AWS account, and also not a lot of storage capacity. So this become possible, and what I would much look at. So probably for quick functional tests, that's okay. And also I see a lot of testing in production, because you have all the real experience, real traffic, real user behavior in production. So a lot of things can only be tested there. And I see a lot of developers which are not quite comfortable that they can't debug locally. There are some third-party solutions for them for local debugging, but generally just it's another way of working. So develop and then automate everything and then deploy on your staging environment, or even with feature toggles and so on, deploy and test everything in production. So now we will go to another point which we'll only cover a bit, because it's a huge point only for itself. This serverless platform and tooling maturity, and different depending on your cloud provider. And we see a lot of choices with infrastructure, especially for example from AWS, automation, CDK, they're all really mature. Terraform is probably not the right. And we also have serverless framework. So I think there we have reached the maturity. There are a lot of tools, and so you can choose depending on the style of your application. And also software as a services, and there's PagerDuty, Shopify, and so on. So this is some kind of growing stuff I see, and even without using the webhook, so you can enrich your application communicating, which is really a good thing, because integration is really important stuff. But what I also see that, especially they only offer the basic stuff for CI/CD with code commit and so on, and for the whole observability, like logging, monitoring, tracing, all this cloud watch stuff, even with alerting and security and everything. They are really good for all basic stuff, but if you to have the deeper dive in your observability of how the things are connected, too basic and not mature enough. So you have to rely on third-party providers for AWS, or the Thunder, Lumigo, Epsagon, and so on, which provide really amazing tools for observability. But of course, what's the right tool for you? But generally speaking, we will at some point in the future solution. Last week, I released Lambda extensions that you can integrate the observability tool of your choice, like Datadog, if you're using this, even easier into the system. So what we can go over, even CloudWatch has some of them. You can search over log groups. You have directly search and analyze environment within log insights, and even you have embedded metric formats to send your logs to CloudWatch logs. So a lot of improvement, but still at CloudWatch. Web up, a lot of reports. You see, they predict that the serverless, and what the same thing I am currently seeing, that that the adoption increases, but there are also challenges ahead. Like we've talked, provide low latency IOPS, ephemeral storage to enable. It's not enough what S3 currently provides. Also, durable storage. It's partially solved with elastic file system, and Azure offers durable functions, but generally you would like to have also a combination of durable storage, SSD-based storage, something like memory storage, like Memcache and so on. It's also currently not possible. Also improve networking and performance, like the functions can communicate quickly within each other, and even if they have higher payload. And also, what I mean by this is, if you have your function the service provider, you select the execution environment, your programming language, like JavaScript, like Python, like Java, and this enables you to build the hardware which is really performant for the environment, and not some general hardware which is a good fit for just all the execution environment. So probably a lot to see in this area. So the other really have AWS, for example, this elastic file system is a huge step, but currently not comparable to S3, because you have a lot of events connected to S3. If you create, and then you can call the Lambda. It's not possible with elastic file system if you do the same thing. And what I really like about S3 is that it's connected to compliance. It's currently not possible to check these things if you use elastic file system, but it will be really nice. Also, other cloud told you it's currently not a match to the third-party services. Also, code commit, this is managed Git. It's not really comparable to Bitbucket, so I see using other services and then use code deploy, even in AWS, but they don't use other code services like code build and so on, because also they only offer basic functionality, and if you are in a just really probably because the huge feature richness that they offer, and you don't want to miss them. Another thing is observability. Only on X-Ray for this, they are very tightly integrated to every service. So just event bridge for synchronous communication, there is no integration. So if you look at the map of the functions, or how they call and chain together, you may see gaps there, and just you feel uncomfortable if you have some serverless services which are not currently tightly integrated. So this should be the day one. So that's all I wanted to say. Just this is just some kind of map how what to decide, go serverless, function as a serverless or not. Just we've talked about understanding your application lifecycle, workload, programming model, platform limitation, also building, especially at scale, organization. So questions, it's probably not just black and white, and then meet your decision. So if you would like to contact me, I'm connected on LinkedIn. So if you have questions, I'm really for the probably audio issues. I don't really know it's my connection or not. I hope you could enjoy the presentation and hear the most parts. So thank you very much.